Okay, here we go, ladies and gentlemen, mole lecture 3, calculating using the mole method. So today we're going to actually learn how do we apply the mole to this whole idea of quantity. We've learned that the mole means that 1 mole of anything is 6.02 times 10 to the 23rd particles of anything, and that's always a good thing that we need to learn. So let's move on a little bit. So how do we solve problems with the mole method? And it's pretty easy to solve problems with the mole method. I'm going to give you a very prescriptive way to do this, and I'm going to tell you that anytime you have a conversion problem, this is what you do. You do this every single time. For example, yesterday, I asked you a question about if a ream is 500 sheets of paper and there are 10 reams per box, how many pieces of paper in a box? And you automatically said 5,000, okay? You automatically told me that there were 5,000 because you knew there were 500 per package, 10 packages, yes? So we're using the same concept that you actually used mentally yesterday to come up with the same ideas, okay? So, first step, okay, we're going to look at a problem. How many cupcakes would there be in 4.34 dozen cupcakes? How many cupcakes would there be in 4.34 dozen? Now, you're already telling me, I know how to do this problem, Ms. Stover. This is stupid. Why are we doing this problem? I already know that you're saying this to me. The point is not that you don't know how to do this problem. The point is that you do know how to do this problem. Right? So I'm trying to apply a method that I know that you know how to use so that you become familiar with the fact that it's the same method you'll use in the future with the new concept of a mole. So what are we going to do? So what's the first thing that we start with in that problem? What are we given? You can talk. There are 4.34 dozen, right? That's our given. So we write the given quantity in unit down on the left-hand side. 4.34 dozen. Now, what are we trying to find? According to this, we're trying to find cupcakes. So I write down an equal sign, I leave a space to put an answer, and I write down the unit I'm trying to find. Now again, I know you're sitting here looking at me going, Ms. Stover, I already know how to do this. Why are we doing this? Remember, we're trying to relate the fact that you know how to solve these problems. You just don't know you know how to solve them. Okay? Trying to take some fear away. So the next thing that we need to figure out is, okay, what goes in this empty space right here? What goes in this, what goes in this empty space right here, right? What are we going to put? Well, the first thing that we need to think about is, what are we given? We are given dozens, so we're going to put dozen on the bottom. Why? Why are we going to put dozen on the bottom? What do we know happens when we put dozen on the bottom? When dozen, well, crap on a cracker, my new thing is not helping me. I don't know where to press, okay? What happens if we put dozen on the bottom? What happens? So if we have X on the top and on the bottom, what can we do with X? We can cancel it. So we always want our given unit to go on the bottom because we always want it to cancel out. So what unit's going to go on the top? How about this one? Isn't that what we want to end up with? Do we have it anywhere in our problem here yet? So we're going to put cupcakes on the top. Now, you can see that the numbers are there. Why are the numbers there? Because you know that 1 dozen is equal to 12 cupcakes. Okay? You know that 1 dozen is equal to 12 cupcakes. So remember, we know that this is good.
Pardon the interruption for the morning announcement. Sorry.
Okay, sorry about that interruption of the announcements. We're obviously during the school day. So we know that if we do this, then we cancel out dozen, leaving cupcakes on the top, yes? We multiply 4.34 times 12, and we get 52.1 cupcakes. So 3.34 dozen is 52.1 cupcakes. So we're going to apply this same concept, this same idea to a problem that all of you are sitting here going, Ms. Stover, duh. Okay, to something new. So here's our method now. First, we're going to write the given quantity and unit on the left. Given quantity and unit on the left-hand side of the paper. So here is the method. Steps to the method. There are 4 steps. The second step is we're going to write an equal sign on the right and the unit we're trying to find after leaving the space for the answer. So we write an equal sign, leave space for the answer, and write the unit we're trying to find. So now we know what our given unit is and what our finding unit is. And I'm going to tell you, in every problem you will do for the rest of the semester, this is the method that you will use. The same exact method we just used to solve the cupcake problem. The same exact method that we just used yesterday to solve the problem of how many sheets of paper are in a box. Okay, so it's no different. It's always the same. Step 3 has some parts to it. The first part is to prepare for converting by drawing the conversion bar. We also call that the picket fence. It looks like this. So you see this over here? This is the conversion bar right here. That's the conversion bar. The conversion bar is this item right here that I just put up, the green bars. Some people call that the picket fence. Whatever you call it, that's what you draw. So you've got your given, you've got your equal sign, and the unit you're trying to find. Now you've drawn a conversion bar. So the first part of that, we're going to write the given unit on the bottom. The given unit on the bottom. Why? Because we always want the given unit to cancel out. The only way that we can assure that it cancels out is we write it on the bottom. Second, we write the finding unit on the top. We write the finding unit on the top. Why? Because we want the finding unit to end up being what we want. So we want to make sure that it doesn't cancel out. And then the third part of this is that now we're going to find a conversion factor. In the case of the last problem, we knew that there were 12 cupcakes in a dozen. We're going to have a little bit of a harder time finding the conversion factors here because they're new to us. But once we find them, then we put the numbers where they go with the units. So the key here is put the units where they belong in the picket fence or the conversion bar, and then add the numbers in later. Okay, you're going to have to determine this. This is probably going to be the part that you get messed up the most. All the other parts are going to be good. This third part is the part that people struggle with the most. But if you follow along, it's actually really simple. And then finally, we're going to calculate or solve and write the answer with the correct sig figs and units. We should already have the correct unit because we should have written it already. Now we just have to make sure we have the correct number of significant figures. So some of us are going to have to go back to significant figures and make sure that we review that. Now I can tell you this, you do not have to review addition and multiplication or addition and subtraction because most of the stuff that we're going to be doing for the rest of the year is going to be multiplication and division. And the rules for significant figures on multiplication and division are much easier. You use the least number of significant figures, and that's what you express your answer in. So whichever number you're given has the least number of significant figures, and you cannot use a conversion factor for significant figures. Did you just hear that? You cannot use a conversion factor for significant figures. Cannot. Okay? So here we go. Mole relationships. So here's the mole. There are 4 relationships. We're going to focus on 2 today, and then I'm going to, well, 2 or 3. And then the fourth one we're going to focus on later. So the first one is representative particles. We already know something about that, don't we? What do we know about representative particles? How many particles are in 1 mole? 6.02 times 10 to the 23rd. Very good. So we already know that there are 6.02 times 10 to the 23rd particles in 1 mole. So every time we see this, we're going to use 1 mole. Okay? And when we're using particles, the number that goes with the particle is 6.02 times 10 to the 23rd. So what number goes with mole? What number goes with mole? 1. What number goes with the particle? So when you have that conversion bar and you're writing the given and the finding unit, you have to recognize, is it a particle unit or is it a mole? If it's a mole, it's always going to be 1. If it's a particle unit, it's always going to be 6.02 times 10 to the 23rd. The next relationship is going to be volume of gas. Volume of gas, or liters of gas. I don't know why mole relationship is right there, but it's going to be overlapping for a minute. Okay? The relationship here between liters of gas and 1 mole is that there are 22.4 liters of gas at something that we call STP, standard temperature and pressure. That's 0 degrees Celsius and 1 atmosphere of pressure. Every problem that you will be doing right now will be at standard temperature and pressure.
What's standard temperature?
Standard temperature is 0 degrees Celsius. Standard pressure is 1 atmosphere. Okay, you are going to assume whenever you have a volume of a gas that you are at STP. The problem will very likely say STP. Okay? So next we have mass, grams, mass and grams. Notice I wrote liters over here on this side. That's the unit, right? Notice right here it's grams. So mole is always going to be the same. It's going to be 1. So if I have liters that I'm looking for, or I have liters in my conversion bar, what number am I going to put with liters for liters of gas? 22.4. Okay, now grams gets a little strange because now we have to find the atomic mass. You actually already know how to do that because you've already done it. You found something called formula mass. Yes? And formula mass is the same thing as atomic mass, except atomic mass is in unit of grams and formula mass is in unit of AMU. So all you have to do is literally change the unit. So if we take H2O, right? It's 1.008. How many H's are there in H2O? 2. So 2 times 1.008 gives me 2.016. And then water, or oxygen, is what? 16. So 16 plus 2.016 gives me 18.016. Does that make sense? That's the atomic mass of water. So if I'm looking for grams of water, I'm going to use 18.016. So the atomic mass you have to determine from the periodic table, which is why you see the periodic table up here. So you have to find out how many atoms of each. You have to multiply that number of atoms by the mass of each of those things. Add that all together, and that mass in grams gives you the number of grams in 1 mole. Now the fourth relationship we're going to talk a little bit more about later, so don't panic about that one. I'm going to have you write it down, but that's going to be part of a little bit of a later venue. Okay, so I'm going to stop right here and I'm going to do some solving of calculations in the next video.